Hello students, let us discuss simplest ratio of number of atoms in a molecule. As we discussed in the previous video, molecules are of two types, that is molecules of elements and molecules of compound. Let us find what is the molecule of compound. The definition we already discussed in the previous video. Let us once again define this compound. Atoms of different element join together in a definite proportion to form molecules of compounds. Here, atoms of different element is the most important point here, and in a definite proportion. These two are most important point in this definition. It shows that the atoms of different element join together in a definite proportion. Definite proportion means fixed ratio. That means the atoms of different element are combining in a fixed ratio. The ratio is fixed here. It gives rise to the molecules of compounds. Instead of molecules of compound, we can use direct word, that is compound. So, in a compound, always the atoms are combined in a fixed ratio. We have already discussed the example. That is the example water, ammonia. These are the examples of compounds. In this, we can find out different atoms are there. What are the different atoms are there in the case of water? There are two hydrogen atom, and we can say there is single oxygen atom. So two hydrogen and one oxygen. They are combined in a fixed ratio. Similarly, when we talk about ammonia, the formula of ammonia is NH3. Here also there is a single nitrogen, and we can say that there are three number of hydrogen atom. So here also the atoms of nitrogen and hydrogen are combined in a fixed ratio. Now the fixed ratio are of two types. We can say they are combined in the fixed ratio by mass and by fixed ratio of number of atoms. So when you look at this table, in this you can find out some examples of compounds are given. That is, example, water is given, ammonia is given, carbon dioxide is given. When you look at the formula, what are the two atoms present in water? That is, hydrogen and oxygen is present, and their ratio, that is, they are combining by ratio. That is the simplest ratio, that is 1:8. This ratio is called as ratio by mass. In the case of ammonia, the ratio by mass is 14:3. In the case of carbon dioxide, this ratio is 3:8. That means you can find it from this table that in all these compounds you can find it out. Different atoms are combining, and they are combining by a fixed ratio. But the ratio which is given here, that is actually, we can say that ratio is called as ratio by mass. That means by mass, when we compare, their ratio will be a fixed ratio, that is called as ratio by mass. But when you look at the formula, you can say that it is H2O. It is not H1O8. It is not H1. You can find it out. It is not H1O8. It is H2O. So here the ratio which actually gives the number of atom, that ratio is called as ratio by number of atoms. So how we convert ratio by mass of an element of a molecule into ratio by number of atoms. So once again look at here. two ratios are there, that is ratio by mass and ratio by number of atoms. So when we find out the ratio, simplest ratio in terms of mass, that time we will be getting, that is ratio by mass. And in terms of number of atoms, if we find out the simple ratio, that is called as ratio by number of atoms. So let us find it out how we can convert the ratio by mass into ratio by number of atoms. For this, you need to make a table in this way. This is the table which is given in your textbook. We have to make the table. In this, we have to keep the columns here. First one is element. Second column, ratio by mass. Third column, atomic mass. Fourth column, that is mass ratio divided by atomic mass, and the last column is for simplest ratio. So what we are doing here, we are converting the ratio by mass into ratio by number of atom. So the last column which we can find out, that is the simplest ratio, that ratio is actually the ratio by number of atoms for that molecule. So how we do this one? So let us take the example of water. First of all, we know that water molecule have two elements in which the two atoms of two elements are combining, that is hydrogen atom and oxygen atoms are present in the water molecule. So you need to make the element, two elements, that is hydrogen and oxygen. What is the ratio of hydrogen and oxygen in the case of water? That is ratio by mass, that you can compare from this table. What the value is given to us? The value is given as 1:8 value is given. So that is the hydrogen versus oxygen ratio, that is 1:8 ratio by mass. So don't get confused. For hydrogen the value is 1, for oxygen the value is 8. So in the table you have to write it in the same order. For hydrogen it is 1, for oxygen it is 8. So we'll write it in the table. For hydrogen it is equal to 1, for oxygen it is equal to 8. So this is the value which we have find it out from the table, the previous table. Now we have wrote the values in the second column. Third column is about the atomic mass. We know that atomic mass, there is a fixed value. Already we have discussed about the atomic mass, which is represented in terms of unified mass U. For the hydrogen atom, the atomic mass is how much? That is 1. For oxygen atom, the atomic mass is 16. So we wrote the second column, that is atomic mass of hydrogen 1, atomic mass for oxygen 16. Now let us discuss the fourth column. How we write the values in the fourth column? Fourth column, that is mass ratio divided by atomic mass. So that means already we wrote the mass ratio in one of the table, that is this table, and atomic mass in this table. So when we divide this value with this value, you need to write the fourth column. So let us write this one, that is 1 divided by 1. So you can see here 1 divided by 1, that is equal to 1. Here you can find out for oxygen atom, the value ratio by mass, we can say for oxygen it is 8, and 16 is the atomic mass for oxygen. 8 is the ratio by mass. When you take the same formula, that is mass ratio by atomic mass. So mass ratio divided by atomic mass, that is 8 divided by 16, that is equal to 1 by 2. So what the values we got here, that is the mass ratio divided by atomic mass that we got here, that is 1 here, and we got 1 by 2 value here. So these we got after making the division here. So let us write that value here. For hydrogen, how much is the value? For the hydrogen it is 1. So write this value here. So that value will be, we can say it is 1. For oxygen, we got 1 by 2. So write that value here. So we can write the value, that is 1 by 2. So 1 is to 1 by 2. So once again I will write this value. So what is the value which we got here? That is 1 is to 1 by 2. We got this ratio. So that is this value we got it. So we are writing separately here. Now this value you have to take in the perfect whole number. It should not be in the fraction. So how we convert this value into perfect whole number? Just multiply by 2. So when you multiply by 2, you will get 2 here is 2, and 2 multiply by 1 by 2. So 2 cancel. So what we got here? 1. That is 2 is to 1. So what we got the value after multiplying by 2? We got the value, that is 2 is to 1. So that is nothing but the value which is written here, that is hydrogen is to oxygen ratio is 2 is to 1 ratio. That means in the water, hydrogen, the number of atoms of hydrogen is 2, and for oxygen, number of oxygen atom is 1. Therefore, the formula of water is H2O. So this ratio is called as this ratio which we got is called as a ratio by number of atoms, because by this ratio only you are making the formula, that is H2O. So this ratio is exactly giving the number of atoms present in that molecule. But the ratio by mass, that ratio is in terms of mass, but this ratio is in terms of number of atoms. So by this table we got the ratio, that is 2 is to 1. Hydrogen oxygen ratio is 2 is to 1. Therefore the formula of water is H2. This 2 you have to take it for hydrogen, H2O. So what it shows, that there are 2 number of hydrogen atom and 1 number of oxygen atom. So there are total 3 number of atoms in the water molecule. Let us discuss next example, ammonia. In ammonia, nitrogen and hydrogen are combining in a fixed ratio to form ammonia. So let us find out what is the ratio by mass for nitrogen is to hydrogen in the table. In this table you can find out the ratio is 14 is to 3 ratio is given. So that is nitrogen is to hydrogen ratio is 14 is to 3. So that means nitrogen 14, hydrogen 3. You have to take in the same ratio here also. So we make the table for this. In this the ratio by mass is 14 is to 3 ratio for nitrogen is to hydrogen. Atomic mass for nitrogen is 14, that we have already discussed in the previous video, and for hydrogen the value is 1. Now divide this value by this. So that gives rise to 14 divided by 14, that is equal to 1. So 14 divided by 14 is equal to 1. So we got the simplest ratio 1. For the hydrogen atom, we also do in the same manner. The ratio by mass is 3 for hydrogen and atomic mass is 1. So 3 divided by 1. So we are doing 3 divided by 1, that is equal to 3. So we got the value 3 for the case of hydrogen and we got the value 1 for the nitrogen and 3 for the hydrogen. So we can say when you compare this value, for nitrogen it is 1, for hydrogen it is 3. So we'll take the same value here. For nitrogen, the ratio by number of atoms we got 1, and for hydrogen we got 3. So the ratio, that is ratio by number of atom, is 1:3 ratio. Now how we make the formula by using this? We will be taking NH3. The formula will be NH3. So that is what the ratio 1:3. Therefore the formula is NH3, that is ammonia. Next example, carbon dioxide. When you look at the previous table, in this you can find it out, the carbon is to oxygen ratio is given, 3:8 ratio is given to us. So let us find out what is the ratio by number of atom. This is the ratio by mass. So let us find out ratio by number of atoms by using this value. So make the table as we have done for the water and ammonia. We have to make the table in this way. So here the two elements are carbon and oxygen. The ratio, that is 3:8 ratio is given. Atomic mass for carbon is 12. For oxygen it is 16. Now we have to divide 3 divided by 12. So we have done 3 divided by 12, that is equal to 1/4. We got the value 1/4. So I'm writing the value 1/4 here. Similarly, we'll be doing for oxygen, that is 8 divided by 16. So that gives rise to 1/2. So I'm writing for oxygen it is 1/2. So we got the value in the fractions. So we have to convert this value into a whole number. So how we convert this one? Divide. Here 1/4 is given, 1/2 is there. So we have to multiply by 4 so that this fraction can be converted into a whole number. So when we multiply with 4, we got here 4/4 and here 4/2. So when you solve this, we will get 1:2. So the ratio we got, that is 1:2 ratio we got. So we can say the simplest ratio, that is 1:2 ratio. So we got the value, that is 1:2 ratio. So we got 1:2. That means there is single number of carbon atom and there are 2 number of oxygen atom. Therefore the formula is, for carbon dioxide, the formula is CO2. So we are getting the ratio here, that is 1:2 ratio. Therefore the formula for carbon dioxide is CO2. So this ratio is called as ratio by number of atoms, and this ratio is called as ratio by mass. That is, this ratio is in terms of mass and this ratio is in terms of number of atoms. So from this example, now we can make one more column in the previous table, that is ratio by number of atoms. So we have taken 3 examples. In these 3 examples, the ratio by mass for hydrogen is to oxygen, the ratio for water that we got is 1:8. But for ratio by number of atoms, we got the value 2:1. That is a formula 2:1. Therefore H2O. Similarly, for ammonia we got the value 1:3, and for carbon dioxide we got the value 1:2. Therefore the formula of water is H2O. For ammonia it is NH3, and for the carbon dioxide it is CO2. So we can say that by this ratio, that is ratio by number of atoms, from this value we can easily make the formula. So by the ratio by mass we cannot make the formula. We can easily make the formula by using this ratio by number of atoms. So this is all about the two ratios which we have discussed in this video. That is, we have discussed about the ratio, that is ratio by mass, and the other ratio, that is ratio by number of atoms. So in this video we discussed that how to convert ratio by mass into ratio by number of atoms by taking the three examples, that is example of water, example of ammonia, and example of carbon dioxide. So this is all about this video. The further details will be discussed in the next video. Thank you everyone.